Good afternoon to one and all present here. I am Dr. P Jawahar, working as Professor and Dean of Faculty of Technology at Kalinga University, Naya Raipur in the state of Chhattisgarh. So I am here to give an overview about this subject, Applied Thermodynamics, BTME 403, which is offered to the students of mechanical engineering. Some students study in the 4th semester, some of them study the same subject in the 5th semester, according to their curricula. So this is a very important subject for the B.Tech mechanical engineering students from the perspective of fundamental principles, basics, etc. So this is an application of the subject which is called thermodynamics. So where one can apply the laws of thermodynamics, the first law of thermodynamics, the second law of thermodynamics. As we know, the first law of thermodynamics deals with the conservation of energy. The second law deals with the entropy. The concept of entropy was introduced by the second law. So this is the very application-oriented subject. So as far as the curriculum of applied thermodynamics is concerned, it is divided into the syllabus is divided into 5 modules. Module 1 to module 5. First module, it deals with the types of fuels. What are the types of fuels? Like solid fuel, liquid fuel, gaseous fuel. What is their calorific value? How much heat they can generate? When we burn 1 kg of fuel, the amount of heat liberated is some kilojoule per kg, which is the calorific value. So this is it's a very application-oriented subject. And the first topic deals with the types of fuels like solid, liquid, and gaseous fuel, and followed by the stoichiometric calculations. Stoichiometric calculation is nothing but the theoretical air-fuel ratio which is required for the combustion to complete. There are 2 types of combustion. One is complete combustion, where C is converted into CO2, and partial combustion where the carbon is converted into carbon monoxide instead of carbon dioxide. The first module of the subject also deals with the air standard cycles like Otto cycle, diesel cycle, dual cycle. Otto cycle is one which is employed in the petrol engine. Diesel cycle, as the name indicates, the cycle was invented by the scientist Rudolf Diesel. It is a principle in which the diesel engine function. And dual cycle, it is purely a theoretical cycle. It does not exist in practice. It is like a combination of Otto cycle and diesel cycle. So this is about the first module of the subject. When we go to the second module of this subject, there is a lot of, emphasis is given for the boilers, types of boilers and mountings. Boiler mountings and accessories are very much essential. Mounting, without boiler mounting, no boiler should be operated. That is mainly meant for the safety of the boiler. Some of the examples of boiler mountings are fusible plug, blow-off cock, pressure gauge. All these things are boiler mountings. One should not operate the boiler without these mountings. If we take the boiler accessories like economizer, air preheater, these are all heat exchangers which are added to improve the efficiency of the cycle, efficiency of the cycle. Then we have the Rankine cycle. The third unit deals with the Rankine cycle, the fundamental cycle, the basic concept which is used in the steam power plant, where we have 4 components, major components: boiler, turbine, condenser, and pump, where the water is converted into steam. The steam is used to generate the power in the turbine, and the exhaust of the turbine, the remaining steam is condensed into water with the help of the condenser, and the water is pumped back to the boiler, that is called feed water, by a pump which is called feed water pump. So how to improve the efficiency of the Rankine cycle? So that is also studied in this module. There are 3 methods of improving the efficiency of a Rankine cycle: reheating, regeneration, and a combination of both reheating and regeneration cycle. So this is about the third module. The 4th module of the course, it deals with the functions of a nozzle. What is the difference between a nozzle and a diffuser? Basically, nozzle is a device used to enhance the velocity of a working fluid. at the expense of the pressure, and the diffuser performs the function just opposite to the nozzle. It increases the pressure and the velocity at the exit of the diffuser will be less. So these devices, especially the nozzle, would be placed before the steam is expanded in the turbine. That is, after the steam is generated, high pressure, high temperature steam is generated in the boiler. That may not possess high velocity. So in order to improve the velocity of the steam, it is this nozzle is used just before the inlet of the turbine. Then in the we study about the effect of friction on these devices like nozzles and diffusers. Then the second half of the fourth unit deals with a very important component that is called turbine. Basically, there are two types of turbines, impulse turbine and reaction turbine. There are plenty of examples for these two types of turbines, like most of these turbines are named in the scientist, by the scientist name itself. And there's another concept called compounding of turbine. This compounding of turbine is done normally if there is no compounding, the shaft of the turbine runs at a very high speed, like 15,000 rpm, 20,000, or even more than that. What will happen if we don't have the compounding? The life of the turbine, there will be more wear and tear on the turbine shaft, that is the output shaft, and the life of the turbine also will go down. In order to prevent that happening, so the compounding is done. Compounding is nothing but there are three methods of compounding, like reducing the rotor speed without affecting the performance of the turbine. There are three methods of compounding: velocity compounding, pressure compounding, and a combination of both velocity and pressure compounding. In velocity compounding, the velocity of the steam is absorbed in the stages. Ultimately, the performance of the turbine will not change, but the speed of the rotor will get reduced. Similarly, in pressure compounding turbine, the pressure of the steam would be absorbed in stages. And in the combination of pressure and velocity compounding, both pressure and velocity will be absorbed in stages. So these type of phenomenon is called multi-staging performed in the turbines. So that is the last portion in the module number 4. And when we come to the fifth module, that mainly deals with the gas turbines and basics of jet propulsion. So if you take the gas turbine, it is the one which is employed in the aircraft. So there is the Brayton cycle. That is the principle in which gas turbine, this one. So you have got gas turbine power plant also. And the reversed Brayton cycle is used in the aircraft as the refrigeration cycle. That is a different one. So if you take the Brayton cycle, there are two isentropic process and two constant pressure process. So there are two types of gas turbine. One is open type, another one is closed type. In case of open type turbine, the air from the atmosphere is taken and it is, after the combustion, it is expanded in the turbine, then it is let out. The working fluid is not reused. Whereas in case of a closed cycle, the working fluid is circulated back. Working fluid is circulated. The working fluid is nothing but the air is the working fluid. So this is generally air is used as the working fluid because it is available in plenty and one doesn't have to spend for that one. And like similar Rankine cycles or similar to Rankine cycle, here also there are three methods employed to improve the performance of the gas turbine. That is intercooling, reheating, and a combination of both. These are primarily adopted to improve the efficiency of the gas turbine. Improve the efficiency of the gas turbine. Mostly, they are used to. They are adopted to improve the turbine output power. And when it comes to the second half of the last module deals with the basics of jet propulsion, rocket engines, and we also study about turboprop and turbojet engines. So this is about an overall view of the subject applied thermodynamics. Thank you.